All right, so we are in Algebra 2. Today's date is Thursday, January 23rd, 2020. Make sure your name and date are on your paper. Our objective today is to do what? Ellery, first hand. There it is. So I will teach you the change of base rule, but let's review the rules that we have thus far. We have the power rule. This is going to say if I have log base b of m times n, this is going to turn into log base b of something and log base b of something with some operation that happens in between here and here. Cheyenne? M, and then I'm going to add the other logarithm, and there it is, because I add their powers. These are a power, that's a power, and I add the powers. Exactly. What about the next one? Beverly?
Log base b of m minus log base b.
Oh my.
All right, there they are. Let me zoom in so we can see these. Again, this is all coming from our last lesson. And then our final one, yes, Jaden?
When are you going to start doing live stream?
Oh, the question? I didn't have any time to work on it last night. Hopefully,
It'll be like a next week thing?
I'm hoping it'll be a tomorrow thing.
Oh.
What about this third rule that we learned last lesson, Caroline?
N times 1 log base m.
There it is, n times log base b of m. All right, so hopefully these three we're comfortable using. We've used them on the homework. All right, and then here is our new rule. So you can say this is our new one, new rule. Our new rule is this: if I have some log base b and I don't like that log base b, I want log base 10 because that can be computed with a calculator. Again, the calculator only has log base e and log base 10. Log base 10 is going to be very helpful for us. I can do, or any logarithm base for that matter, it's going to be, this is equal to a fraction. It's log base whatever you want to choose. So I'm going to say x. You could choose 10, you could choose e, you could choose 2. Log base x of the inside, so m, divided by log base, that same base for the base.
Mr. Sandell, emergency?
Emergency, yes.
My nose is bleeding, can I leave?
Yeah. So this change of base formula is, it looks easy on paper, but it's kind of difficult if you see going in reverse. You have to be able to notice, oh, these both have the same base. I can turn it back into this logarithm. You need to be comfortable going forwards and backwards, where you expand it and condense it, both directions. Question, Maria?
So when do you use this method?
You use this if you need to calculate logarithms that are to decimals that there's no way to calculate. Like if I have log base 2.7 to the 98, like there's no way of doing that. The only way to do it is to put it on a calculator, and the calculator doesn't have any bases aside from base 10 and base e. So I need to change it both to base 10, for example, or you could do e. And then I can do 87 or whatever number I said on the top, and then 2.7 on the bottom. So it's used to calculate things that we don't know how to solve yet. I guess maybe another way of formatting this lesson is I show you a problem that we can't solve and I say, here's the solution. It's this rule. Well, here's example 1. We can't calculate this any other way without using the change of base formula. Actually, I think maybe newer phones have a function that allows you to have any base. So maybe technology is catching up with these rules, but let's pretend that we have old-fashioned calculators that don't have the ability to do other bases. I need to do this, and let's see if my calculator here. So I have log base 10 and I have natural log, ln. Natural log is log base e, so I only have this button. There's no log base random number on this calculator, so I'm going to change these both into log base 10. So I'm going to say this is going to be log base 10 of blank over log base 10 of blank, and it's always going to be the inside 10, and then on the bottom it's going to be whatever the original base was. You guys can actually solve the numerator right now. What power does 10 need to be raised to get 10? This is a what power function. What power does 10 need to be raised to in order to get to 10? Is there a quiet raised hand that can do that for me? India?
1.
Exactly, this is 1. And log base 10 of 3, we don't know. unless you're really, really good at just memorizing random logarithms. So I have to come back over my calculator and I say, yeah, so I have 3, and I take the log base 10 of that, and I get 0.477. I'm going to round to 3 decimal places. So 0.477. 0.477. And if you don't like that calculator, you also have, where is it? Yeah, your Desmos scientific calculator.
I tried Desmos, doesn't like bases.
Yeah, so if you just say log of 10 divided by log of, what is it, log of 3, it'll give you the answer. 2.09. And let me zoom in here so you can actually see what I'm talking about. That's the same thing as 1 divided by log of 3, which is almost the same thing as 1 divided by, what is our decimal? 0.477. Oop. 0.477. All of those are the same fraction, well, roughly. This one is rounded, right? So that's why I can turn it into a fraction that isn't actually true. So the correct answer here is 2.096. We'll just do 3 decimal places. So this is equal to 2.096. 2.096. But generally speaking, go ahead and just enter this into your calculator. And again, remember that if I don't have a base here, or rather you're not eating seeds or anything, right? If you are, can you please stop? If you have log base 10, I could have written this as just log of 10 divided by log of 3. If I don't have a base, I automatically assume that it's 10. So it's another way of writing the same thing. This is the same. Yeah, question?
If the base is already 10, why do you need to do this?
If the bases are not 10?
Well, because you said for the orange thing, you said if the base is already 10, then you could write it like that.
Yeah, so either way, this is a faster way of writing it because you don't have to write the base. So I was going to write it like this, but I feel like people would have been confused.
If you want the thing, I get it now. That makes sense.
Okay. So what I want everyone to do is try out example number 2. You're going to be using calculators on your computers, hopefully using the Desmos calculator, and you're going to have a fraction, log of something divided by log of something. So everyone try example 2 out on their own, and then we'll talk about example 3 as a class. All right, quiet raise hand. Who can set up the entire fraction? Who still has their card that could do this for us? Beverly, do you still have your card? No. Who has their card? Should we make sure I can see your ears?
Can I try?
Yeah, go for it, Leo. Log 1 over 17. Keep going.
Again, the below is the same.
Log of. Careful, it's log of the base.
3.
Yep, log of 3. So we just enter that into the calculator. Thank you, Leo. I'll take your card. So I come back over here, and again, just making sure it's always the log of the inside divided by the log of the base, and you're good. And again, I can choose whatever base I want here. I'm choosing 10, that way I can save some writing time. So come back down here. The log function, by the way, is a function. So you can type in log, or you can just type in the letters L-O-G, and it will turn into a log. So log of 1 over 17, and that all divided by log of 3. And we get negative 2.579. I'm rounding to the 3rd decimal place, so negative 2.579. Negative 2.579. I feel like we should have an unspoken rule of whenever we should round to. Can we, like, if I don't say, can we assume that it's 3 decimal places? Because that's what it's going to be for AP Calc if you guys take that, which I hope most of you will. Question, Anna.
How do you enter it into the calculator again?
So you type in log of 1/17, and then you divide that by log of 3.
Okay. When I was trying to do it, it tried to put like log 1 and then the divide by and then 17 on the bottom.
Oh, like this. So if you had log of 1 and then divide by 17 like that?
Yeah.
Oh, yeah, in that case, you just have to click back up inside the 1, hit divide by, and then you can get the 17
Okay.
over log of 3. All right. There's example 2. Let's talk about example 3 before I let you guys move on. I need to use one of the old tricks because I don't like to have a coefficient in front of my logarithm. I need to put this 2 somewhere else. How can I move that 2 around? I need to change this into log base 7 of something. What is that something? I see 2 hands. Those are my good backups. I'm trying to get cards in. I'm going to just cold call, I think. Yeah, Loria. 4 to the power of, yep, That 2, you're allowed to move it up to the power. It's that third rule that was back up here. If I have this power up there, it can be out front or it can be up here. These are interchangeable. It can go up there or it can come down here. Either way. Yeah, thank you. All right, and then that is the same thing as log base 7 of 16. And now I need someone else with a quiet raised hand to tell me how to use the change of base formula to actually calculate this guy. Change of base formula. Who's got this? Colby.
Log of 16 over log of 7.
Log of 7. Perfect. Let's go ahead and enter that into our calculators to figure out what that is. I'll do it for you. Log of 16 divided by log of 7. Oop. And we get 1.425. 1.425. Question, Leo.
How'd you get 16 again?
Say it one more time.
How'd you get 16?
Oh yeah, so this 2 on the coefficient moved up to the power. 4 to the power of 2 is 16. 4 times 4 is 16. Yeah, good question. So again, this was 1.425. I'll come down here. 1.425. Other questions? I like all these questions. If not, then we're moving on to the backside. Example number 4, multiple choice now. Which of the following is equivalent to log base 7 of a times log of 7? Ooh, that is going to be a tricky guy. So I'll work with you guys on this one. If you ever see a base of 7 or base of something random, you should automatically think in your heads, change of base formula. So I see the 7 and I immediately think, change of base formula. I'm going to rewrite this as log of a divided by log of 7. I have now rewritten log base 7 of a. And now I'm going to rewrite times log of 7 on the right hand side. Times log of 7. Quiet raised hand, do you guys notice something? Something that'll make it nice and easy? Sorry about that, Caroline. Preferably someone that still has their card. Anna, do you still have your card?
Yeah,
What do you notice about this?
the A disappears.
Not the aid that disappears. I have something on the top and the bottom.
The divide by disappears.
This division, yeah, so you're
The
really
top
close.
The top log disappears and the bottom goes to the top.
Not quite. So I have log of 7 on the bottom and log of 7 on the top. It's like having a 2 on the top and a 2 on the bottom. What do I do with these?
You cancel them out.
Yeah, they cross cancel. So cancel them out. Correct answer is log of A. Thank you, Anna. I'll take your card.
Okay.
We are now on to example number 5. Which of the following is equivalent to these things? I'm going to let you solve this one. The hint that I'll give you is you're going to use the change of base formula twice. All right, good luck. Go. All right, so we are on example number 5. I need someone to do the first initial setup of doing change of base formula twice. Someone preferably that still has their card, but I do have a lot of good backups. If I'm going to cold call, I'll only make them do it once. Sam, go for it. Log of 9, perfect. Someone else. Someone that still has their card. Who still has their card? The boys have their cards over there.
No, I got it.
That's Ziri, go for it. Good. Say it one more time. Yeah, log of B, perfect. Someone else, quiet raised hand. What do you notice? What can you get rid of? Chewy. The 9s. Log of 9, log of 9. Let's cross cancel them. Chunk, chunk. I'll take a card. And I'm going to rewrite this. What's left on the top? I have log of A on the top. What's left on the bottom? Log of B. But now I need to go backwards. So whatever's on the top, that's whatever was on the inside. So how does that work? And I can let some repeats in now, because this one is kind of the hard one. India.
The answer is going to be log base of B and then a parentheses.
Yeah, and that makes sense. Yeah, perfect. Because that inside is always on the top and the base is always on the bottom. So yeah, log base B of A, correct answer is D. Thank you. All right, you guys are actually doing so well that I was going to talk about example 6 together, but I want to see if you guys can do it. My hint to you is keep it, change it, flip it. You'll need that rule. Keep it, change it, flip it. Let's see how many can solve this, because I was assuming it was going to be like 0 or 1, but I'm thinking I can get 2 or 3 of you to do this. My hint for you also is not only keep it, change it, flip it, but this denominator is the same thing as log of a over 1. I don't know if that helps you that much, but yeah, keep it, change it, flip it. You're definitely using the change of base formula. Good luck, guys. I'll give you guys like 2 minutes and see if you guys can solve this. Yeah, so I am super, super impressed that so many people were able to get this by themselves. So again, we did the change of base formula on log base 2 of a, so you get log of a over log of 2. Log of a over log of 2, and I should have let someone do the participation for that, but I'll let someone else do the participation now. You can either do a division symbol, or you can do a multiplication symbol. Quiet raised hand. I'm only going to give it to people that still have their card, though.
Well, that's what I was asking.
I'm not if you can.
Well, I know I can, but I was asking if you did.
Who has their card still?
You asked me to plug it in.
Aurelia, do you have your card?
Yes.
All right, go for it.
Can I just explain to you how I did it?
Yes.
So what I did was I rewrote log over a, or log a, and then over log 2.
Okay.
And then on the other side I put log a and then over log 1.
Log of a. Why'd you do log of a over log 1? Like, what operation did you have in between here? Is this a...
I just did it like that. I didn't have an operation. I just,
Okay.
and I canceled out the ones at the top.
You cancel out those two?
B didn't have it too, so then I just went to D. That's how I did it.
Okay, you're really, really close. So I'm going to go and leave this like log of a over log of 2 divided by log of a divided by 1. So I've rewritten the same fraction. Just instead of having this division symbol here, or this like fraction symbol, I change it into a division symbol. That's all I did. So now when I have a division symbol, whenever I have a division and a fraction, I change this into a keep it, change it, flip it. So I keep it as log of a over log of 2, and then I change the division to a multiplication, and then I change it to 1 over log of a. I flipped it. I took the reciprocal. The log of a's cancel out, and you are left with 1 on the top. You're left with log of 2 on the bottom. Correct answer, D. Cool, that concludes notes. I need everyone to give me a fist of 5 on our objective today. Again, our objective was to use the change of base rule. All right, let's go around. Starting with Ellie. Fist of 5, how well can you do today's lesson? 5, 3, 4, 3.5, 4, 4, 3.5, 4, 4, 4, 4, 5, 3, finger wave 4.
That's a 4.
4.5, 5. 5. Nice. Yeah, those are really high scores for this type of lesson. I'm impressed.